In this section, we're going to be talking about the graph of a function. We talked about functions in the previous section, and now we're going to look at graphically what that would entail. Let's recall, for a function, each x that is in the domain has exactly one and only one image of y in the range. The graph cannot have 2 points with the same x value but different y values. In other words, for every x, there has to be only one y that it goes to. An example of not a function is an x that will go to 2 different y values. This is not a function. So in a graphical format, we can determine what that's going to look like by using what is called the vertical line test. A vertical line test says that if a vertical line intersects a graph more than once, the graph is not a function. So let's look at this graph right here. Which of the following graphs are functions? This graph right here, if I were to draw a vertical line through this graph, anywhere through the graph, it's only going to hit one time. It doesn't matter where I draw this vertical line, it will only hit one time. That tells me for this particular x, there is only one particular y. For this particular x, there is only one particular y. So this is a function. For this graph over here, if I draw a dotted line, you'll see it crosses the graph 2 times. When it crosses the graph 2 times, that tells me for this particular x value, you're getting 2 y values. So this x is going to one y value and to another y value, which means this is not a function. Over here, this graph, even though it's discontinuous, meaning not connected, would depend on what are the endpoints. If these were, in fact, 2 solid circles, meaning at this particular x, I have 2 y values, that would not be a function, because this vertical line would pass through at this one location 2 times. Now, if I redrew that graph, and let's say those endpoints, it looked like this. So let's say one was closed, meaning it was included, but the other was open, meaning it wasn't included. A vertical line through there would actually only pass through the graph one time. Since this point is not included, then this yes would be a function. So you have to pay special close attention to whether the endpoints were included or maybe one of them was not. For the ellipse down here, passing this vertical line through the graph is going to hit 2 times. So for this particular x, it's going to hit the graph at 2 y values. So this is not a function. For this trigonometric function, you see that a vertical line will only pass one time. So this is a function. Moving on to number 2. To obtain information from a graph of a function, first let's recall back to what we talked about in the last section, that every function is equal to y. This is our output. So y is the value of the function at x, and x comma y, or we could call it x comma f of x. Since f of x and y are essentially the same thing, this will be a point on the graph. Let's recall, this is the input, this is the output. So let's use this graph to answer these questions over here. So I have this graph with a couple of key points that have been labeled on here, and it's asking me to find f of 0. So in other words, 0 is the input. I plug 0 in for x and find out where the function would be the output when x is 0. So I come over to my graph, that is my x-axis. On my x-axis, when x is 0 is right here. This point right here says when x is 0, the output is 0. So when the input is 0, meaning the x is 0, the output is 0. So f of 0, input, equals an output of 0. F of 5, when I plug 5 in for x, so my input is 5. So I go to my x-axis, my input is 5, so this point right here. When my input is 5, my output is 0. When my input is -2, so here's -2 in the x direction, so when my input is -2, 1 will be my output. When -5 is my input, 2 will be my output. We can also discuss whether the function is positive or negative. So for example, if I wanted to find f of 1, 1 would be my input. So I go over here to x is 1. When x is 1, that would be roughly this point around here. I don't have an exact coordinates for where that point is, but it's somewhere around 1, around -2. I don't know exactly what that value is, and it doesn't really matter. The question is just simply asking, is f of 1 positive or negative? So it's asking you, if I want to replace all of this with y, I can do that. At this point, when x is 1, is y positive or negative? Well, when x is 1, you can clearly see that y is going to be a negative value somewhere near -2. How about when f is f of -1? So that states when x, or my input, is -1, when x is -1, is f of -1, or we can call this y, is y positive or negative? So when x is -1, you're going to see that the y is going to be some positive value somewhere near 1. I don't know exactly what it is, but it's definitely positive since it's above the x-axis. Some more questions from the same graph. So we have to use the same graph to answer some more questions. For what values of x is f of x equal to 0? Again, sometimes it's helpful to cross off f of x and call it y. So for what values of x is y equal to 0? So we look at our graph. This is the y-axis right here, which is also equal to f of x. So on the y-axis right here, where is y equal to 0? Well, right here. And the only point that y is 0 on this whole graph, when y is 0, right here, you see x is 0. But there's actually another point, okay? Also, when y is 0. So y is 0 here, but also here. When y is 0, you see x is 3. Also, when y is 0, x is 5. So x can actually be any of those 3 values. For part D, for what values of x is, again, we can call this y, is y less than 0. Well, if this is my y-axis, the y-axis is less than 0 anywhere down here. So the graph anywhere below the x-axis, any of this area down here, means y is negative. And you can see that by the points that it creates. The y value is negative. So any graph is negative, has a function that is negative, if it is below the x-axis, because that's where y is negative. So I'm looking for, on my graph, any point that is in this area, any point in this green shaded area is a point where y is less than 0. So I have to express this green shaded area by finding what are the values of x in this green shaded area. Well, the values of x are anywhere from here, which is 0, all the way to 3. And the endpoints are not included. There's no underscore. So the endpoints are not included. So I want just the graph underneath. So I will not include these endpoints. So anywhere between 0 to 3, not including the endpoints. So x can be any number between 0 to 3. What is the domain of f? The domain of f is basically the x values. So when it's asking for the domain, it's looking for all x possible values. So if I look up here, I see x is -5, x is also -2, but also x can be any number in between there as well. So it could be any number from -5 all the way to -2. In fact, x can be any number from -5 all the way to +5, and any number in between there. So x can be any number from -5 included all the way to 5, and that endpoint is included. The range is all sets of y's that are possible. So I'm looking for all y's that are possible in this graph. Well, y goes as low. The lowest point on this whole graph would be right here. This is the lowest point. Its y value is -2. So it starts as low as -2. It's included because there is an actual point that hits -2. And then it goes as high as this value, which is 3. So again, for domain, you're looking for all the x possibilities. Where does it start and where does it end? For the range, you're looking for where does it start on the lowest end and where does it end on the highest end. So you're moving vertically to find range. You're moving horizontally to find domain. Find all the x-intercepts. Well, there's x-intercepts at 0, 0, 3, 0, and 5, 0. It's the points at which the graph crosses the x-axis. So at 0, 0, 3, 0, and 5, 0. Find the y-intercepts. There's only one y-intercept. The only point where it crosses the y-axis is the origin. So notice that the x-intercept and the y-intercept are actually the same point when it's at the origin. How often does the line y equals -1/2 intersect the graph? So if I look at the graph and let's say I plug this equation and I graph it right up here in blue, y equals -1/2. So I come to my graph where y is -1/2, which is right here, and then I graph a line. It wants to know how many times does that blue line intersect the graph. You can see that it intersects the graph here and here, so the answer would be twice. Now for how often does the line x equals 1 intersect the graph? The graph of x equals 1 is going to be a vertical line at x is 1, so it's going to cross through here. It's going to be a vertical line through x is 1. And it wants to know how many times that line intersects the graph. The only place it intersects the graph is one time, which is right here. One time. For what values of x does f of x equal 3? So again, if you treat this as y, sometimes it's easier to understand on the graph. It wants to know what values of x will y equal 3. So if you look at the graph, you're looking for a point where y is 3. You're looking to find the x when y is 3. So we look, where is y equal to 3? The only place y is equal to 3 is this point right here. 4, 3 is the only point where y is 3. So for what values of x, I would say x equals 4. For what values of x does f of x equal negative 2? Well, again, let's call this y equals negative 2. So where on the graph is y equal to negative 2? Well, y is negative 2 right here, and the only point right here where y is negative 2 is this minimum point at the very bottom of this curve. So at this point right here, y is negative 2, which means x is 3/2. Now to obtain a little bit more information about the graph of a function. For example, if we have a function which is 2x over x minus 2, we're going to answer the following questions. Is 3, 6 on the graph? Well, 3, 6 is x and y, and we know by definition f of x is y, so all we can do is take 6 for y, and let's plug that in, and take 3 for x, and we'll plug that in. So let's rewrite this by plugging in 3 for x and 6 for y. So that means 6 equals 2 times 3 over 3 minus 2. And we ask if those two sides are equal. 6 equal to 6 over 1? Yes. So that means this point is on the graph. So when x is negative 2, what is the function? In other words, what is y? So what we do is we plug x as negative 2 into the original, and we determine what the output is. So that means f of x, which again we know is y, is equal to 2 times negative 2 over negative 2 minus 2, which is negative 4 over negative 4, which is positive 1. So f of x equals 1. If the function, or y, is equal to 3, what is x? So we're going to take y is 3, plug it in for y, and solve for x. So that means 3 equals 2x over x minus 2. I'm going to multiply both sides by x minus 2 so I can cancel out the denominator. So that gives me 3 times x minus 2 equals 2x. If I distribute, I get 3x minus 6 is equal to 2x. If I subtract 3x to both sides, that gives me negative 6 equals negative x. And then when I multiply both sides by negative 1, I get x is 6. Finally, what is the domain of the original function? Well, remember the original function was this fraction. And if I'm looking for the domain, you always start with all real numbers. Then we take exclusions. So we're going to exclude any number that does not make this side of the rational expression definable. What will make this undefinable is if we get a 0 in the denominator. So we have to set x minus 2 not equal to 0, because this denominator may not be 0. So that means x may not be 2. So we have to exclude 2. So we would say x as the domain can be any number except x cannot be 2. Or in interval notation, we could say be any real number from negative infinity to 2, or we pick up again at the other side of 2 and go all the way to infinity. So you could state your domain either way. List any intercepts. Well, if remember, for intercepts, if I make a small little table, to find X-intercepts, if we want to find an X-intercept, we set y equal to 0 and we find the x. To find the Y-intercept, we put x equal to 0 and find the y. So these are going to be the two intercepts of my graph. So let's first find the X-intercept. So if I say y is equal to 0, I have 0 equals 2x over x minus 2. Again, if I multiply both sides by x minus 2, that gives me 0 equals 2x. And when I divide both sides by 2, I get x is 0. So that means x is 0, which is the origin. Now if we do it the opposite way, if we say x is 0, well, I kind of know what I'm going to get, but I'm going to follow through and do the problem anyways. That means y equals 2 times 0 over 0 minus 2. 2 times 0 is 0 over negative 2. 0 divided by anything is in fact 0. So that means if y is 0, again, I get the same point. Sometimes they're different points, sometimes they can be the same point. The only time they will repeat and be the same point is if it's the origin, because the origin would be both an x-intercept and a y-intercept at the same time.